Hello my dear students, welcome to our channel MS2 Physics, where physics gets charged. In the last videos we have discussed the concept of differentiation and basics equations of differentiation, and also we have discussed how we are using differentiation in our physics. And now today in this video we will discuss the concept of integration and basic concept of formulas of integration and how we are using this integration to our physics. So before going to know the use of this integration in our physics, first we will discuss the basic fundamentals of this integration, right? So if you are taking any function is the f of x, if this function is changes according to x, the total change of this function with respect to x is denoted by integral f of x dx. This is the x elongated s is the symbol for integration. Simply integral is the symbol for this integral. Means we can write f of t dt, means this function is in terms of t, how it will be changes according to time is denoted by this, right? So here in this, when I am coming to some basic formulas, the first one is integral x to the power of n dx is there, so that we can write x to the power of n plus 1 by n plus 1, but the condition is n should not be equals to minus 1. Sir, why is the taking minus 1 is not equals to n, sir? If it is n is equal to minus 1, what happens? Say here in this formula, if you are taking minus 1 plus 1, something by 0 is undefined. So then if in the function, if n is equal to minus 1, sir, for that we have the different formula, is that integral 1 by x dx is nothing but x to the power of minus 1. So for this we have the log x base e. And again another is integral only dx we have, means nothing will be there. So means we can write integral dx is the x, integral dx is the x, or you may write integral dt is the t, means you are integrating with respect to what, that only you will get on integrating the function without any function, means here is a constant, means we can write integral k dx. K is not the function in terms of x, so k is a constant, so we will write k into x is the k dx. Like in the differentiation we have d by dx of x to the power of n is what, n into x to the power of n minus 1. Similarly here in the integration, integral x to the power of n dx is x to the power of n plus 1 by n plus 1, but n should not be equals to minus 1, right? Another we can take integral e to the power of x dx is again e to the power of x only, right? So now another I am taking here integral sin x dx is a minus cos x, integral sin x dx is a minus cos x, and if you are taking a integral sin kx dx, means here the function is in terms of x, but k is the coefficient which is a constant, so in this case we can write a minus 1 by k into cos kx into cos kx. Similarly here when I am coming to integral cos x dx, integral cos x dx can be written as is a sin x only, and the same function if they are given as cos kx dx, so this is equals to, we can write 1 by k into sin kx, 1 by k into sin kx. Okay, again, so integral secant square x dx is equals to tan x, integral sec x tan x is equals to sec x only. Like again integral cosecant square x dx is equals to minus cot x, and in this only we have one more, integral cosecant x cot x dx is equals to again minus cosecant x, right? So these are some basic formulas which we are using here, and now we will take some use of these formulas, how we are using these formulas operating onto a given function. Let me check now, right? Suppose we are taking integral 3x cube dx, say for example. So here this 3 is a constant, we can write outside, so integral x cube dx, right? So here it is in the form of integral x to the power of n dx, so that we can write x to the power of 3 plus 1 by 3 plus 1, so we will get a 3x to the power of 4 by 4. This is the way we are using this formula to a given function here. If you are taking the composite function, means integral, if you are taking 3x square plus 2x dx, suppose. So here we can write this integral to the individual functions, means 3 integral x square dx of the individual terms here, plus 2 into integral x dx you can write now. So then after say 3, it is integral x to the power of n dx form is there, so that x to the power of 2 plus 1 by 2 plus 1 plus 2 into integral x dx, nothing will there is power 1. So again here you can write x to the power of 1 plus 1 by 1 plus 1. So that here you can write 3x cube by 3 plus 2x square by 2. So we will get here x cube plus x square is the final answer for this integral 3x square plus 2x dx here. Suppose if you are taking integral sin x plus cos x dx is there. Okay, so in this we can write here at first integral sin x dx plus integral cos x dx, So integral sin x dx is equal to what do you know, minus cos x, plus integral cos x dx is a sin x. So that the final answer is sin x minus cos x is the integral of sin x plus cos x dx, right? Not only in the function in terms of x, if you are taking function in terms of t, say for example integral 5 t cube minus 5 t square plus 2t plus 6 dt is here. So again composite function, right? So now in this we can write 5 into integral t cube dt minus 5 integral t square dt plus 2 integral t dt plus integral 6 dt, right? So now at first this is equals to 5 into t power 3 plus 1 is a 4 upon 4 minus 5 into t power 2 x to the power of n plus 1 by n plus 1, 2 plus 1 3 upon 2 plus 1 3, 2 into power is 1, so t power 1 plus 1 by 1 plus 1, 6 is a constant, integral dt is what, t only. So that here we will get the final answer as 5 t power 4 by 4 minus 5 t cube by 3 plus t square plus 6t here. So up to now whatever we have previously discussed are said to be indefinite integrals. So now when you are coming to the definite integrals, means we have the limits of this function 0 to 2. So in this problem minus 1 by 2 to 2, this is called lower limit, this is called lower limit, and here it is called, otherwise here it is called upper limit. Always whatever the limits are there, the bottom one is said to be lower limit, the upper one is said to be upper limit here. So now how we are using these limits to this given function, let me check now. So when I am coming to this problem integral 2t dt, so that we can write it to integral t dt 0 to 2, which means after integrating this function, wherever the t present, at first you have to substitute this upper limit, minus at the same place you need to substitute the lower limit, which means here this is equals to 2 integral dt is what, t square by 2. Why? Because t power 1 plus 1 by 1 plus 1. So 0 to 2 here, this 2 get cancelled. So when is the 2 get cancelled, now wherever the t is present, there you should substitute the upper limit, means of 2 square, minus at the same place of t you have to substitute the lower limit is a 0 square. So the value of this is said to be 4 only, right? So this is what called a definite integrals. These are we are using especially in our physics, okay, for to know the change in physical quantity from one point to another point, or from one time to another time, or one position to another position. How it is we will discuss in the further videos, right? So now let me check only the mathematical part of this integration in this video, right? So here in this, can I write this one as minus 1 to 2 2t dt minus integral dt minus 1 to 2. because of this is a composite one, right? So now here we can write 2 is a constant. So integral t dt is a t square by 2 of the limits minus 1 by 2, 1 to 2, minus integral dt is a t of the limit minus 1 to 2 here. So now as this 2 get cancelled, here wherever the t is present, there you should substitute the upper limit. Here in the given problem, upper limit is a 2, so it will become 2 square minus lower limit is a minus 1 whole square again, and here also minus of upper limit is a 2 minus of minus 1. How I am substituting the limits here? So 2 square is a 4 minus 1 square is a 1 minus of 2 minus of minus is a plus 1. So 4 minus 1 is a 3 minus 3. So its value is 0 in between these intervals. Means now see the importance of this definite integrals is the same function. Okay, it gives the different values with respect to the limits we are chosen. As that these limits of this integration are changes, the final value of this change in function will also be changes. Understood? If you are taking 1 to 2, you won't get this. If you may take 2 to 4. So why I am taking these limits, sir? I will explain with respect to physics, right? So now I am coming to this here when I am coming to integral sin x dx. So once again I am writing here integral sin x dx. Lower limit is a pi by 6 and upper limit is a pi by 3. So what is sin x dx? Integral sin x dx is a minus cos x of the limit pi by 6 to pi by 3. Okay, so now the meaning of this is wherever the x is present, there you have to substitute the upper limit, minus at the place of x again you have to substitute lower limit. I am taking this minus outside the bracket. So can I write this as cos pi by 3 minus cos pi by 6, cos pi by 6. So that here minus of cos pi by 3, it means of what? Cos 60. Okay, when it is a cos 60, cos 60 is what? 1 by 2 minus cos pi by 6 is a 30, cos 30 is a root 3 by 2. So therefore we can write by sending root inside, root 3 minus 1 by 2 is the value of sin x dx is from pi by 6 to pi by 3 is nothing but 30 degrees to 60 degrees. If you are changing those limits from 0 to pi by 2, again these values are changes. Why? Because when you are substituting 0, it's a cos 0, it's a cos 90, cos 90 is 0, cos 0 is a 1, its value will become 1. Means again see, I am repeating the same, the given function is varies according to position within the given limits. When the given limits are changes, the function, the final change in function will also be changes. Now I am coming to this here, integral cos x dx, integral cos x dx. So cos x dx right from 0 to pi means 0 degrees to 180 degrees. Integral cos x dx is what? Sin x of the limit 0 to pi. So that upper limit minus lower limit means wherever the x is there, you have to substitute pi at that place, minus at the same position of x, you need to substitute the 0 degrees or 0. Sin 180 is what? 0 minus sin 0 is also be 0. So its function is 0. Means again this function, how does it changes within these limits is called definite integrals, Means before learning these things in the physics, so first of all you need to know the basics of this in a mathematics. Then after we are implementing this all these things to the physics. Why? Because whatever the given function here, when I am coming to physics, here it is one is the physical quantity. How does this physical quantity changes with respect to this in this limit is the use of this definite integral in our physics here. Like that, sir, so many problems you may take from basics of mathematics and solve yourself, and in the next video we will discuss this uses of integration, okay, in a physics, and how we are deriving the equations of motion by using this integral method. Thank you for watching. If you like my videos, do like, share, comment and subscribe our channel to get more videos.